this prosumer use case is, if you've already seen the previous smart home use case, it's something that's related, but not quite related, because it's about a small household size solar power plant, which also has energy storage as a battery. And it may be part of a smart home, but in a different way, because mostly why it's different is because it uses industrial protocols as communication. And this is how we want to be different, at least in this this pilot. So it is also consisting of off-the-shelf components. So we don't develop these components, obviously. We just buy the solar panels, we just buy the inverter, we buy the battery controller, we buy the data logger. It is integrated together as a network, and these components are just forming an internal, like a local network in the home, or in this case, in our one of our sites. Actually, this prosumer cell here is already in operation for at least 2.5 years now. So it's working and it's generating power, and it's used as a test bed for some predictive maintenance algorithms and also some remote management technologies, some new remote management technologies. And the unique thing is that it's both remotely manageable by the owner itself and also by the power utility company, because it's connected to the power grid. And of course, the power utility company must be able to make it stop and make it limit its output during the peak hours, and make it store the energy instead of outputting to the grid, something like that. So these are the main goals. So in contrast to the smart home has many small devices. All of them serve just one purpose or two. This one has a few, this smart inverter is remotely manageable, but it has just like 1 or 2 commands. You can limit the output power, and that's it. The battery controller is also remotely manageable, but it just gives you the current state of charge of the battery, not much more. And also we have weather sensors and some smaller sensors which measure the temperature, wind speed, and solar irradiation, something like this. But the main thing here is that this is about remote management. How do we remotely manage such a site? There are 2 different options, and this is what are usually used in such systems. Either this industrial style local network, as in Modbus, if someone is familiar with industrial networks. This kind of industrial style local network is nice because it's standard, it has very low overhead, and it's very easy to integrate the different devices, nearly all such devices. So if you want to buy an inverter from one company and the battery management from another one, you can integrate them easily. Just they all speak Modbus, you give the Modbus addresses, and they just see each other and they work. And it's very easy to change to a different device. But these interfaces, they use Ethernet, but they are designed for a local network. There is no security. There is no access control, nothing like that. You just set the address and it works. So it is not suitable for a public internet. It needs some form of gateway and some form of security. So you can't go to the public internet, obviously, with this approach, but it's easy to use. Then there is the manufacturer's own solution, which each and every different manufacturer has its own. And it's nice because it also uses Ethernet. So you plug in the same Ethernet plug, and it just goes to the manufacturer's cloud. It's very easy to use if you use the similar devices from one manufacturer. But if you don't, if you buy different devices from different manufacturers, you may need to use different cloud solutions, and they won't speak to each other, or maybe they are very hard to set up to speak to each other, but it solves the security. So neither one of these is or was good for our purpose. The cloud-based solution was good for security, but bad for almost everything else, because then we won't be able to change just anything in our system, and of course, not all the functions may be available through this interface. So actually, our inverter has a lot more functions available through its internal industrial style interface than through the cloud. This was also a problem. And also there's about downtimes. You can't schedule the downtime for a Huawei cloud. If it's down, then it's down and you can't access your stuff. So that's also a problem. So what we did actually in the precursor of this project, in the IoTech project, we have our own self-developed solution, which uses the modules developed in the IoTech project. So we connect to our actual prosumer cell to all our devices. It's just simplified as one box through the internal Modbus TCP, so the industrial data bus. This connects to our own local industrial PC, which uses the IoTech developed modules, which handle the access control, the data collection, the attack detection, and some attack mitigation as well. And through this thing, we can finally connect to the public internet, either to each and every client device, which uses our own API, our own small application to control this device, or we can collect our data to our own server, which is a self-hosted application. So it's in our cloud-based solution, but it's a self-hosted application that we have control over. And this is as it is. So this system already works in this way. What we want to achieve from DOSS is mainly two things. First, we'd like to test this existing architecture, so this one, how secure it is and how standard compliant it is in terms of security. For this, we want to prepare this digital cybersecurity twin for this architecture, for everything that's in this local PC up to this point, up to the Modbus TCP port, because we of course can't model the devices which we don't own. We can only model with what we have. So we want to model this architecture in a cybersecurity point of view, and then we will use that cybersecurity twin. So first we will use a cybersecurity twin to check it against errors and check it against like hidden bugs and something. And then we will use the same cybersecurity twin to try to integrate new sensors. We have new sensors planned, and we also have a new software component planned. We will try to integrate those, but first we will integrate those on this cybersecurity twin. And if everything goes according to plan, then we will deploy it to our actual working solution without like disturbing its operations. And I think that was it. So thank you for your attention.